Hi, my name is Ayana, and I'm going to be talking about contact metamorphism. Alright, so, hold on. Here you go. Alright, okay. What is metamorphism? What is the word? What does it mean, Ayana? It means to change. It means in geology that rocks constantly change physically and chemically to form a new rock, a new creation. So with metamorphism, it is formed when existing rocks are changed by great amounts of what? Heat and pressure. So that's something to keep in mind. So going to the types of rocks. So now we know what metamorphism is. What is contact metamorphism? Well, it's a type of metamorphism that forms basically what? It's literally in the title. Basically, it's when existing rock comes in contact with hot magma or lava. So that's basically what it is. It's in the name. It comes into contact. So, and the hot magma goes into the intrusion of the rock. So when I think about contact metamorphism, I think about, okay, I'm walking down the street. I'm walking down the sidewalk. I got my hot coffee, probably from Starbucks. And the coffee, I trip over a rock and the coffee spills out and it gets into the cracks of the sidewalk. And that's how you can think of a contact metamorphism, is when the coffee is within the cracks. The hot magma goes into the intrusion of the rock. And so, oops, my bad, we're not there yet. So, contact metamorphism does not foilate. Foilation means it's directional or shear pressure onto rocks, and it forms mineral banding within the rock, so you won't see that with contact metamorphic rocks. So it is formed under low pressure but high heat. It's not as high with the rock for the rock to melt. So the ranges of temps is 300 C to 800 C, but it's enough for the rock to change or even crystallize. Any type of magma body can lead to contact metamorphism, from a thin dike, again a sidewalk, hot coffee in a sidewalk, to a large stock. So this is an example of an areola or areole. Don't know how to say it, but this is an example of contact metamorphism. It looks like a balloon. So around this red balloon, you have this purple shading. That's the thermal metamorphism. And then the second phase, which is labeled B, you see the magmatic water, which is the release of magmatic fluids. And then C, it shows the convecting of groundwater and also the magmatic water. This can form metallic minerals. So that's pretty cool. All right. So my example is when you flat iron your hair. So for me, my natural state, or AKA my parent rock, is curly hair. As you can see, my hair is curly, but when I put a flat iron to it, like she is in this example, you see that the hair is not curly anymore. It's formed into straight strands from what? Again, heat and pressure. Heat coming from the inside tongues or blades within the flat iron, and the pressure is coming from me pressing the flat iron together to flat iron my hair straight to a natural form. Another form, I meant, my bad. And this is my example of contact metamorphism. So these are examples of rocks from contact metamorphism. You got hornfels, you got marble, little colors there. You also got quartzite. So these are just a few. These are from the textbook, but you can find loads of many examples on Google. So now we know what contact metamorphism is. Okay, so what's the difference with regional metamorphism? What's the difference? I don't understand. Well, regional, think about it this way, it has a lot of pressure. So contact is more heat. Regional has more intense pressure. And because of that intense pressure, the rocks are foliated. And because it's foliated, it has more mineral bands within the rock, which is perpendicular of the directional or shear pressure on the rock. But with contact, it's just coming in contact with hot, again, the cracks of the sidewalk is coming in contact with the hot coffee. And so there's not a lot of pressure there. So keep that in mind. Regional is when rocks are buried deep in the crust. And with contact, it takes place where a body of magma, that balloon I showed you, that red balloon of magma, intrudes into the upper part of the crust. All of this happens within the Earth's crust. Okay. All right, that is it. Here are the sources besides from the textbook where you can look on your own and search more into the topic. So, bye. Thanks.